All right, so we're going to do like we've done with our other rules so far, and we're going to look at some examples. So we're going to start with 4 to the 5th divided by 4 to the 3rd. So this is the kind of thing we're talking about today, where we have something raised to a power divided by something with the same base raised to the power. So we're going to remember that 4 to the 5th means 4 times 4 times 4 times 4 times 4, multiplied together 5 times. And 4 to the 3rd means 4 multiplied by itself 3 times, 4 times 4 times 4. Well, since I'm multiplying and dividing this way, I can cancel all of those out. And I just end up with 4 squared. Now let's look at another example. This time with variables, x to the 6th over x squared. Well, x to the 6th is x times x times x times x times x times x divided by x times x. We have the same thing going on here. So I can cancel this one with this one with this one. And we just end up with x multiplied by itself 4 times, which is x to the 4th. Can we see what's going on with those exponents there? We're subtracting. So that's going to be our rule. And we could write 4 squared, 4 times 4 is 16 if we wanted to simplify it further. So our rule. Dividing a power by a power. And we're talking about things with the same base. Here we have 4 and 4. Here we have x and x. Dividing a power by a power with the same base, we subtract the exponents. And in symbols, we would say a to the m divided by a to the n is a to the m minus n. We subtract the exponents. And let's think back for a second. When we multiplied a power by a power, what did we do with the exponents? We added the exponents then. So we're doing the opposite operation on the powers. We're dividing. So this time we subtract. All right, so let's look at a few examples. Two to the 6th divided by 2 to the 3rd. We have the same base. So we're going to apply our rule, and what do we get? 2 to the 3rd. And if we wanted to simplify this further, we would say 2 times 2 is 4, times 2 is 8. If we had variables, doesn't change anything. X to the 12th over x to the 6th. Same base, we have a power divided by a power. So we get x to the 6th. We subtract the exponents. Easy. I want to do one more example just to remind us of something that will come up sometimes. X to the 3/4 divided by x to the 1/2. Fractions. Well, because they're fractions, it doesn't change anything. Nothing changes. So I'm going to write this as x to the 3/4 minus 1/2. Now we could just put these 3 divided by 4 in our calculator, 1 divided by 2 in our calculator, and subtract, we get a decimal. Usually with exponents, we want to write them as fractions, and we'll talk about why, I think next week when we do a little more with these fraction things. So we need to remember how to subtract fractions. I need a common denominator. My common denominator is going to be 4, so I'm going to multiply this by 2 over 2. So when I do that, I get x to the 3/4 minus 2/4. And when we add or subtract fractions, we add or subtract the numerators, the top, and we leave the common denominator. So this is going to be x to the 1/4. If you did this in your calculator, 3/4 minus 1/2, you get 0.25. Usually you're going to see these exponents written as fractions. All right, questions on our fraction thing there? Okay, let's look at one more example with a little more going on. A to the 4th, b to the 8th, over a to the 6th, b to the 3rd. So we have powers divided by powers, and we're going to deal with the same bases. So we're going to deal with the a's together and the b's together. We're not going to mix them. So for the exponent on a, I'm going to subtract these exponents. 4 minus 6 is -2. And for the b's, 8 minus 3 is 5. Oh, but now we have this negative exponent. So to simplify, we don't want that negative exponent. What are we going to do with that a to the -2? Yeah? We're turning it into a fraction. So this goes to the bottom, and what happens to our exponent? Turns positive. So we get b to the 5th over a squared. And this would be my final answer. All right. Questions there? Okay, the last thing for today is raising a quotient to a power. So again, we're going to look at a couple of examples because I think we'll be able to see what's going on here. 2/3 to the 3rd power. Well, 2/3 to the 3rd power means multiply this thing by itself 3 times. So that's 2/3 times 2/3 times 2/3. And when we multiply fractions, we multiply straight across. Well, this is 2 times 2 times 2 on the top, which is 2 to the 3rd. And this is 3 times 3 times 3 on the bottom, which is 3 to the 3rd. And I think we can see what's going on there. Let's look at one more just to make sure. X over y to the 5th. Well, this is x times x times x times x times x over y times y times y, whoops, times y, times y times y. We're multiplying straight across. Well, I have 5 x's multiplied together here, so that's x to the 5th. I have 5 y's multiplied together there. That's y to the 5th. So can we see what's going on there when we raise that to a power? It's just like the product to a power we talked about yesterday. We raise everything to the power. So that's going to be our rule. quotient to a power. We raise everything to the power. And I'm going to add one other thing and then simplify. So, for example, here, 2 to the third over 3 to the third. 2 to the third is 2 times 2 is 4, times 2 is 8. 3 to the third, 3 times 3 is 9, times 3 is 27. So we'd write this as 8 27ths. X to the fifth over y to the fifth, we can't really do anything else with that. And in symbols, this would be a over b to the n equals a to the n over b to the n. We just raise everything there to the nth power. All right, so we're good with our rule. Okay, let's look at a couple of examples, and we'll be done for today. So we have w to the fifth over 4 to the third power. So I'm going to raise everything to the third power. So I get w to the fifth to the third power over 4 to the third power. Well, now I have, in the numerator, I have w to the fifth to the third power. I have a power to a power. What do we do with the exponents here? Multiply. So this is going to be w to the 15th. 3 times 5 is 15. And 4 to the third. 4 times 4 is 16. Times 4 is 64. So this would be my answer simplified. Power to a power, multiply there. Questions there? Okay, let's look at one more with a little more stuff going on. 3c to the third over a squared, and we're raising that to the negative fourth power. Quotient to a power. We're going to raise everything in here to the negative fourth power. 3 to the negative 4. C to the third to the negative 4 over a squared to the negative 4. Well, let's deal with these exponents first, so I'm going to leave this written as 3 to the negative 4 for now. Here we have a power to a power. We multiply the exponents, so it's going to be c to the negative 12. And here we have a power to a power, so we multiply the exponents, a to the negative 8. Now we have all these negative exponents to deal with. So we have this 3 to the negative 4. So what do we do with that 3? Put it in the bottom. We make the exponent positive, so I'm going to get a 3 to the 4th on the bottom. How about the c to the negative 12? Same thing, right? Now how about this a to the negative 8 in the bottom? That goes up to the top, and my exponent becomes positive. And then we could write c to the 4th as, 3 to the 4th, get a to the 8th. 3 times 3 is 9, times 3 is 27, times 3 is 81. Yes? So this would be my final answer after we simplify everything. All right, questions? Okay, so today are two rules. Quotient to a power dividing with exponents, same base, we subtract the exponents. And a quotient to a power, we raise everything to the power. And then simplify. That's our two rules for the day. Okay. This is section 7.4. Page 442, 8 through 86, every other even. And just a reminder, every other even, that would be 8. Skip 10. Skip 14. Skip 20, etc.